Hi again. In this quick demo, I want to introduce you the new disaster recovery capabilities of Spike as of version 0.3.0. So for more information, you can visit this website down here. It is spike.ist, Architecture System Overview. This page kind of has more detail about the overall Spike system design, Spike components, and a bunch of more detail about how various components play together, how the overall architecture fits out. But in this particular demo, we are more interested in how Spike root key is sharded and split and kind of protected, and how the disaster recovery happens based on the shards of that root key. If we zoom into this diagram, Spike has two components when it comes to maintaining the root key. One of them is Spike Nexus. Spike Nexus is the secret store, so it keeps secrets essentially. So assume that we create a couple of secrets. Let's say these ellipses are individual secrets that are created in the memory of Spike Nexus. So Spike Nexus keeps the secrets in memory, but it also has a backing store on the disk. And to save those secrets in the backing store, by design, Spike's backing store is assumed untrusted. So those secrets are encrypted with a root key that you see down here before they are being put into the backing store. So when the Spike Nexus crashes or is restarted, it needs this root key to read the secrets back from the backing store and to reinitialize them into the memory. But the problem is this root key is never stored on disk. It's on the memory of Spike Nexus. So when Nexus crashes or when Nexus restarts, the root key is gone, and therefore anything that's encrypted is undecryptable because the root key is not there. To sort this out, we have the concept of Spike keepers, and those keepers are little services that are distributed geographically across the network, and we use Shamir's secret sharing algorithm to split the root key in shards and then distribute them to keepers. So in the default implementation in this depiction, you can see that we are splitting the root key in 3 separate shards, and then we are dispatching those shards into the Spike keeper instances. And all of these connections are guaranteed and secured by SPIFFE MTLS, and therefore we know the authenticity and the reliability of Spike Nexus and Spike keepers, so the connectivity is guaranteed to be secure and cannot be eavesdropped. So that's good. And the root key here and also those shards that we have dispatched to the keepers are always in memory. We don't store them on disk. The benefit of splitting them into shards is a single shard cannot create the root key back. You need a threshold number of shards to be able to recover the root key. In our sample scenario, it is 2 shards. So I need to get 2 shards to recreate this root key. This gives us certain possibilities. For example, if Spike Nexus crashes and then it kind of restarts, it can ask the keepers to get 2 shards back. So if it can get 1 shard from one keeper and another shard from another keeper, and by using those shards it can recreate that root key. And when it creates the root key, it can recalculate all of those shards back, and this can work in other way too. So for example, if one of those keepers is gone, then the Spike Nexus can send the shard that the keeper needs back to the keeper. That way the system will recover itself essentially. So as long as we have a root key, we can like reseed the keepers with the shards that they need. And as long as we have enough number of shards in the keepers, we can recreate the root key. So in a scenario that Spike Nexus has crashed and like one of the keepers has crashed and then the system is brought back up again, so we know that this keeper and this keeper has shards. So Nexus can like fetch two shards, the green one and the orange one, and based on those shards it can recompute the root key. Based on that root key it can recreate all of those shards internally in its memory. And like this purple shard was missing because the keeper has crashed before, but since we recomputed this shard, we can send that purple shard back to this keeper, and then the system is back to normal. We have all the shards in the keepers and the root key is in the memory of Nexus, and we have also reinitialized the backing store with the root key, so we can decrypt the secrets in the backing store and the life will go on as usual. The problem with this thing is like what we call the Doomsday scenario. If like instead of one keeper, let's say like two keepers have crashed. So let's say in a disaster scenario, like this one is gone, this other keeper is gone, we only have this top keeper that has the shard, and in the meantime while this is happening, like the Nexus is gone too. And this is typically unlikely because the keepers in an ideal production scenario, the keepers are geographically distributed. So having two geographically distributed keepers crashing at the same time and the Nexus is crashing, which is typically on a different geographic area, is really low, really unlikely, but it might happen. And that's where the manual disaster recovery or like a Doomsday scenario can take place. So let's say for the sake of argument that this happened and we only have, after the complete system restart, we only have this one and we don't have the root key. The Nexus has brought itself up and we don't have the keeper number 2 and keeper number 3 don't have any shards. So what Nexus will do is it will try to fetch enough shards to be able to recreate the root key, but it won't be able to. It will get the first shard, but whenever it contacts to the other keepers, it will get a 404, I don't have any shard response. And that will make it in a waiting state all the time, and it will not be able to recreate the root key. So how we can solve that problem is, like when the system is healthy, we have two commands we have introduced to Spike Keeper. One of those commands is, let me write it down, Spike operator recover, and the other command is Spike operator restore. So restore by its name implies it will going to restore the shards back into Spike Nexus's memory. So if we restore 2 shards, then based on those 2 shards we can recreate the root key, and if we have the root key then we can calculate the remainder of the shards, and then we can reinitialize the system since we have all of those shards back. And Spike operator recover, on the other hand, is responsible for getting out the shards from Spike Nexus while the system is healthy. So when we execute Spike operator recover, we get a threshold number of shards in 2 separate files on the user's local file system. Premise of this thing is we take those shards and then keep them securely until we need it. And when we need it, we can use the Spike operator restore command to get those shards back. So I urge you to like go Spike ist architecture system overview and like read it for yourself to get a better grasp of how things are working internally. While we are at there, I can show you a bunch of other links. So this is the system overview, and also we have like the security model document that explains in more detail about what is the trust boundaries of the system, how the attack surfaces are designed, what are our assumptions when we secure the system, and how we can like do a production like Spike deployment essentially. So yeah, it's spike.is. And while you're at that, like you can click this star us button and like give us more power, because the more GitHub stars means that the more people will be aware of this amazing technology essentially. So let's dive into the demo. I'll just pull the recent code because I don't know if it's recent. And I am going to run make start. This command will do a bunch of things. It will first start Spire server and Spire agent. It will then initialize 3 Spike Keeper instances, and it will start Spike Nexus along with a bunch of registration entries to the Spire server so that the system can get its identities and the components of the system can talk to each other. So let's start that one. I'll split this view as well. I can see the things are running by doing a like ps aux grep nexus will show that I have a Spike Nexus instance running. If I do keeper, we can see that we have 3 keepers up and running on the system as well. So let's run Spike. For example, if I do Spike secret list, we can see that we don't have any secrets. So we'll just create a test secret to just make sure that when things crash, we can read that secret back. So if I do a Spike secret put tenants acme db creds user root pass Spike racks, and if I do a Spike secret get tenants acme db creds, we'll get the password and the username as stored in this path essentially. So the secret store is running. I'll do again ps aux grab nexus. So it's up and running. What I'm going to do is I'll kill this process, copy, kill this one. Spike Nexus is gone. When I reboot Spike Nexus, as long as the keepers are up, things should just work fine. Let's try that one. I'll restart a Spike Nexus down here. For this, I'll do hack start Nexus. So let's check what's happening in the logs. It says like it initialized its backing store, its recovery is successful. It talked to 2 keepers to get the shards. We get 1 shard from 1 keeper, we get another shard from another keeper. We initialize the backing store with the recomputed root key from those shards, and the recovery is successful. So if I do a Spike secret get tenants acme db creds, we can get the secret that we have from the database. So if I do like a Spike secret list, I can see that I have it in the database. So things are working perfectly because we were able to restore the crashed Nexus's root key by using 2 of the 3 keepers that we have. So we'll do a more dire scenario right now. Instead of like just crashing the Nexus, I'll crash all the keepers and also the Nexus and then do a Doomsday recovery. But to do that, first I need to save the shards somewhere. So for this, I'm going to do a Spike operator recover. And when I do this, it will say, hey, you need to have a certain privilege to do this recovery operation. So we have 3 separate users. Like one of them is the super user. It can do any kind of operation like creating secrets, creating policies to define which workloads can read or write those secrets. But it cannot do any recovery. And there is a recovery user that can only do recovery, and there is a restore user that can only do restoration using the recovered shards. This gives a better auditability in the system. Let's say that like I have my Spire server in a separate place and my Spike Nexus and Spike Pilot is in a separate machine and my keepers are in a separate geographic location essentially. This way, the only way in this Spike Pilot to use the Spike operator recover operation is someone on this machine assigning recovery privileges to this binary, which means I can have two separate users. One of them is to enable this recovery operation and the other one to do the actual recovery operation. Typically it's the same administrator, but again it gives us the flexibility and also it leaves a trail of events that gives us the auditability essentially. We'll know exactly what happened on the system and who logged into the system to enable recovery or change those registration entries on Spire server. And better control over the security of the system by distributing trust. I can run hack Spire server entry recovery register.sh. And when I do that, it will create a entry on Spire server to enable for me to do Spike operator recover operation. So I can now do Spike operator recover, but for example, I cannot do Spike secret list. When I do that, hey, you don't have authority to do this operation. You can only do recovery. This gives like separation of concerns or separation of roles and responsibilities essentially. And in the meantime, you can see that Spike Nexus is still sharing its shards to the keepers to keep system in sync. So let's do that. Let's do a Spike operator recover. It will say I saved some stuff here. So I'll copy this path and I have these two files. I'll just cat them so that it will be handy when I need to use them later down the line. So this is the first one and this is the second one. We will need these when we need to restore. So what I'm going to do is I'll kill Spike Nexus down here and also I'll kill all of the keeper instances as well. Enter, do again. So I don't have any keepers. I'll do for Nexus again. I don't have Spike Nexus. So essentially my entire system has collapsed. So let's try to recover from that Doomsday scenario. Luckily we have these shards down here. And as suggested here, ideally we should have saved these shards in a secure place outside the system, and we should have wiped out these files securely from this file system. But for the sake of this demo, I'll just copy them. I'll first start with starting Spike Keeper. Start Keeper 1. This is our first Keeper instance. Hack start Keeper 2. And I'll do the third one. Start Keeper 3. So I have these 3 Keeper instances, but the problem with those are right now they are just waiting. They don't have any shards in it. And these are my keepers, and I'll put my Nexus down here. So let's do that one as well. Hack start Nexus. So it tries to talk to keepers. It tried to fetch shards from the keepers. It got no data. There's no data that's coming from either of the keepers, and it eventually says, "Hey, I tried my best, but you kinda sorta maybe have to manually bootstrap the system." Let's say that I'm not looking at the logs. As a Spike user, let's say I am trying to use the system. But before this, I want to revert back to my super user account because I was using the recovery account. So Spire server entry super user register. So now I am super user, so I can do things like Spike secret list or like Spike secret get, whatever secret it is. So let me try to do Spike secret get tenants ECMADB, and I get a boom, like a warning. Spike is not initialized, like wait a few seconds and try it again, but we know that even if we wait for a few seconds, we will have to manually bootstrap the system. If the problem persists, you may need to manually bootstrap the system by using Spike operator restore, hoping that you did recover first, of course. And for more details, go to the manual and read some details about how this thing happens. So that's some helpful instructions. So let's try to do it. I guess I need to do Spike operator restore. Spike operator restore. And it will say, oh, by the way, you need to become a restore user to do this. So let's do that. I need to change my privileges again to be able to do restore operation. Like I said, it's for better auditability and trackability. So let me paste this one. I'll assign myself a different SWIT, and this way I can do the Spike operator restore operation. Let's do that. Spike operator restore, enter. It will ask a shard from me. I'll copy this one and paste it here. It won't be visible while I paste it, but if I copy it correctly and I paste it, it will accept. Now it says I got one shard, I need one more shard, please run the operator recover again. And I'll do as instructed. Then I'll enter my second shard, copy and paste here, enter. And now the recovery operation is completed. It says like there's a success here. It sent the shards back to the keepers. So things should be alright. So to verify that, I'll register as a super user again. I'll wait for a while for the entries to propagate to Spire server. And now if I run that Spike secret get tenants ECMADB creds again, I'll be able to get the password that I set in the system. And if I do a Spike secret list again, I'll be able to list that secret, which kind of finalizes this demo. For the sake of this demo, on showing how Spike is resilient enough to recover from most of the crash situations automatically, and how to do a Doomsday recovery when everything has crashed. That's all I have to share. And until next time, keep your secrets secret.